Good day and welcome everyone. Today we'll be solving fundamental problem number 12 of chapter 2, force and vectors. In this problem, we'll be defining the magnitude of the resultant force and its direction measured from the x-axis counterclockwise. So here we have three forces, F1, F2, and F3. F1 and F2, we need to find its x and y component by using similar triangle technique. And for the F2, it does not have any x component. It has only y component because it is directly acting along the y-axis. So we need to find the individual x and y component, and then we'll be finding the resultant horizontal force and resultant vertical force. And then by applying the X2 formula, and after that, for direction, we'll be applying the trigonometric ratio, the tan theta formula. We'll get the direction for the resultant force. So here I will be starting from the F1 force. So I'll be constructing for the F1 force a large triangle. Here we have this F1 force, and it is acting downward. So here we have the small triangle. So the y component will be acting on this way, and the x component for the F1 force will be acting on this way. So the direction of x component is on the right side, so it will be positive, and the direction of the y component is downward, so it will be negative. So the F1x will is this component, and Fy will be F1y will be this component. So we need to find the value of F1x and F1y. So for this, I'll be applying similar triangle technique. We have this large triangle, and also we have a small triangle, which is this small triangle. So we'll be applying similar triangle technique for the F1x. I'll be applying in this way similar triangle technique, that the base of large triangle divided by the base of small triangle will be equal to the base of large triangle, which is F1x, divided by the base of small triangle, which is 4, will be equal to the hypotenuse of large triangle, which is 15 kilonewton, divided by the hypotenuse of small triangle, which is 5. So the F1x will be equal to 12 kilonewton. So its direction on the right side from the origin, so it will be positive. And for the F1y, I'll be applying similar triangle technique. Now I'm taking the perpendicular of large triangle, which is F1y, divided by the perpendicular of small triangle, which will be 3, equal to the hypotenuse of large triangle and the hypotenuse of small triangle. So the F1y is acting downward. Here you can see that the F1y is acting downward, so it will be negative. So the F1y will be equal to minus 9 kilonewton. So we found the value of the horizontal and vertical component of the F1 force. Now we'll be doing for the F2 force. So for the F2 force, we know that it has only y component. So for the F2, the x component will be equal to 0 because it is directly acting along the y-axis. So it means that it has only y component. It does not have any x component. So now I will be defining the F2y. So it is acting upward, so I'm taking it as positive. It has directly equal to the F2 force. So the F2y will be equal to 20 kilonewton. So it is directing upward, so it will be positive. Now I will be finding the horizontal and vertical component for the F3 force. So I will be resolving the F3 force into 8x and y component, and the x component will be acting like from here in this way. So this will be the F3x, and the y component is acting upward. So this will be the F3y. So both value will be positive because the x component is acting from the origin on the right side, and the y component is acting upward. So both will be positive. So for the F3x, F3x is same. I will be applying similar triangle technique, like the base of large triangle, which is the F3x, divided by the base of small triangle, which is 4, will be equal to the hypotenuse of large triangle, which is 15, divided by the hypotenuse of small triangle, which is 5. So the F3x will become equal to 12 kilonewton plus 12 kilonewton. Now I'll be finding the y component of the F3 force. So I'll be applying the same similar triangle technique. Now I'll be taking the perpendicular of large triangle, which is the F3y, divided by the perpendicular of small triangle. In this case, we have the perpendicular of small triangle, which is 3. It will be equal to the hypotenuse of large triangle divided by the hypotenuse of small triangle. The F3y value will be equal to the 9 kilonewton. So it is directing upwards, so it will be positive. So we found the value of the all three forces, its x and y component. Now for the FRX and FRY, we'll be applying summation of the individual horizontal forces and individual vertical forces respectively, and then applying the magnitude formula, we'll get the value of the resultant force. So for the FRX, I'll be adding all the individual horizontal forces. So F1x, F2x, and F3x. So the FRX will be equal to F1x value is the algebraic bond, which is 12, plus F2x value is 0, plus the F3x value is 12. So the FRX value is 24 kilonewton. Now we will be doing same for the FRY. FRY will be adding now the y component of individual forces F1y, F2y, and F3y. So now I'll be putting the value of F1y, which is the already found, which is -9, plus F2y value, which is +20, and plus F3y value, which is 9. So the FRY is equal to 20 kilonewton. So we found the FRY and FRX. So now we'll be applying the magnitude formula. So magnitude formula, then we'll get the value of the resultant force. So the resultant force will become equal to the FRX square plus FRY square. So putting the value of the FRY and FRX. So the FRX value is 24 square plus FRY value is 20 square. So the resultant force value will be equal to 31.2 kilonewton. So this is the value of the resultant force. Now I will be finding its direction. So for direction, I will be applying trigonometric ratio. So the theta will be equal to tan inverse Fy divided by Fx. Fy divided by Fx. We already do know the value of Fy and Fx. Now in this case, it will be Fry and Frx, the resultant component. So because we are finding the direction of the resultant force, that's why we'll be taking the FRX, FRY, and FRX. So putting the values, so tan inverse Fy value is 24, and the Fy value is 20. The Fx value is 24. So the theta will become equal to 39.8 degree. So this is direction of the resultant force, and this is the magnitude of the resultant force. So I hope in this video lecture you found that how to calculate the value of the resultant force and its direction. It was very easy because we already calculated these resultant force and its direction in previous lecture too. But here we have only two similar triangle technique. We applied that and we get the value of the resultant force and its direction. So thanks to everyone.